Find the area of the semicircle. We reconstructed the semicircle to be a circle. For easy explanation, label points B, C, D, E, and G. Join line D, E, line C, D, and line B, C. Let line D, G equals to X. It implies that line B, G equals 3, X, as line BD equals 4, X. Also, angle CED equals theta. Hence, angle CBD equals theta. It is because angles in the same segment are equal. Again, let angle BCE equals to beta. It signify that angle BDE equals beta. It is because angles in the same segment are equal. Consider triangle BGC. Line CG divided by sine theta equals line BG divided by sine beta. Substitute values and we have that 3 divided by sine theta equals 3 times X divided by sine beta. Cross multiply and we have that sine beta divided by sine theta equals 3 times X divided by 3, which equals X. It implies that sine beta divided by sine theta equals X. We call it equation 1. Consider triangle DEG. Line DG divided by sine theta equals line EG divided by sine beta. Substitute values and we have that X divided by sine theta equals 4 divided by sine beta. Cross multiply. Hence, sine beta divided by sine theta equals 4 divided by X. We call it equation 2. Equate equation 1 and equation 2. It implies that X equals 4 divided by X. Cross multiply and we have that the square of X equals 4. Take the square root of the equation. Hence, X equals the square root of 4, which equals to 2 units. Label point M. Locate center O of the quarter circle. Join line OD which is equals radius R of the quarter circle. This implies that by Pythagoras theorem, the square of line MC equals the square of 3 minus the square of 2 which equals 5. Take the square root of the equation. It signify that line MC equals the square root of 5. Hence, line OM equals R minus line MC which equals to R minus the square root of 5. Consider triangle MOD. Line MD equals 4 and line OD equals R. By Pythagoras theorem, the square of R equals the sum of the square of line MD and line OM. Substitute values and we have that the square of R equals the sum of the square of 4 and the square of R minus the square root of 5. Simplify further and combine like terms. We now have that 2 times the product of the square root of 5 and R equals to the sum of 16 and 5 which equals to 21. Divide the equation by the product of 2 and the square root of 5. We have that r equals to 21 divided by 2 times the square root of 5, which equals 221 times the square root of 5, divided by 10 in units. After rationalization, therefore, area of the semicircle equals half the product of pi and the square of r, which equals to the product of 441 in pi, divided by 40 in square units. After substitution and simplification of numerical values.